definitely at the right place right now because we're going to be talking about the state of production machine learning. This talk is going to be fascinating. It's going to be really good. We have somebody who's been working on AI for over a decade now. As a hobby, he contributes to tech policy. That's kind of like his hobby, and that's also the reason why he's one of the AI experts for the UN. He's director at Zalando. Please raise the roof for the amazing, the fabulous Alejandro Saucedo.
Great. So thank you, everybody, for joining today. We have a really interesting topic to dive into. We're going to be talking about the state of production machine learning in 2024. So to tell you a little bit about myself, so my name is Alejandro. I am director at Zalando. So Zalando is one of the largest European fashion e-commerce companies, 50 million customers, over 1.8 million articles, as well as a large scale of the data that comes with it. And I'm also elected board member at the ACM and AI expert at the UN. Today we have a very interesting set of topics that we're going to be diving into on the topic of AI, production AI. So we're going to talk about the motivations, we're going to talk about tech trends and industry trends. So these three things are some of the key things that you will be going out with today. So to start with the motivations, right? Like, why should we care about this? What are some of the market trends, some of the opportunities, and some of the challenges that have to be taken into consideration? So let's take a look at basically the history of AI, right? And the reason why I put this is because it goes very far back in time, right? All the way to the 1800s, back into the discovery of things like linear regression, the first neural network. And the reason why I'm putting this going from the birth of the perceptron all the way to generative AI is to highlight that when it comes to us considering basically the assets that we have available in the machine learning ecosystem, there is a sort of like battle-tested foundation that we can rely on, right? Which is basically being in industry, we know how it works. Things like support vector machines, gradient boosted trees, etc. And even RAG that we're hearing about in LLMs, that is coming from its roots in the 70s, right? In 1970s. And of course, there's still the more emerging areas, which is where it's the high risk, high potential. And that's what we're going to be talking about. But the AI market in numbers, so we know it's growing, right? So it's almost 200 billion in valuation. It's actually a very fast projected growth in the next 7 years with a compound annual growth rate that keeps just increasing. And we are seeing this not just in the numbers, but also in the success stories, right? We've also heard about some of the companies, like GitHub, which they've made some significant value profits opportunities within Copilot. There are organizations in the pharmaceutical therapeutic space which are using things like fraud detection to actually, save and recover a lot on the payments, and also innovative organizations that are using conversational agents to drive incremental value in their businesses. But at the same time, we do hear the success stories. It is also important to consider the challenging and emerging risks, because we also hear some horror stories. And as part of this, we know that there are some challenges with AI. Things like algorithmic bias, things like outages caused by the complexity of the AI systems themselves, and also something that is perhaps not talked as much as it should is cybersecurity risks. And I think we're going to touch upon some of that today. Some of the nuanced complexities, these are because AI systems are different to traditional software systems, right? So we're dealing with complex orchestration and monitoring. The actual hardware where it runs, it has more specialized requirements, larger memory, specialized compute, TPUs, GPUs, etc. We have some complex data flows, right? It's not as simple as just like a request-response microservice, but it's a flow where something going wrong actually affects upstream and downstream. And also, there are multiple considerations on reproducibility and compliance, right? So making sure that what you run once can actually be rerun the next time, right? So, and now what we have actually seen as a consensus is that the life cycle of the machine learning model begins once it's trained. Or is that correct? Well, let's have a look. So once the model is trained, we deploy it, right? Perhaps then we see that the model, sees an outlier, right? And we need to like reconsider basically the data that was used. There's some drift in the data or drift on the model, concept drift. There needs to be a new model superseded by this one, et cetera, et cetera. So indeed, we have to realize that the actual life cycle of the machine learning model begins once it's trained. And this is what we're going to be delving into in this talk. So let's start with some of the technology trends. And we're going to be delving into 4 things: trends in tooling, architecture, monitoring, and security. So let's actually get started on the tooling. And let's actually reminisce, right? Like back in the day, it was simple to get started in the field of machine learning and MLOps. So this is how it started, and this is how it's going. So navigating the state of machine learning is complex, and you may ask yourself, how do I pick the right tools? How do I pick the right libraries in order to actually maximize our value? This is what we're going to be thinking about it today. So that's going into the architectural considerations. One of the key topics to take away today is this transition going from an AI model to an AI system, right? So we can think of the machine learning models as taking an input and then providing an output. However, right now we're evolving to a situation where we don't have just a single machine learning model, but we actually have a system, a machine learning system that evolves from the capabilities of science to actually organizational capabilities. And this considers basically not just the inputs and outputs to the model, but the actual use case and the business value that comes out of those complex contexts. And this really requires us to think of how to bring the best practices on software engineering into AI. Now, when we think about the systems themselves, and we ask ourselves, well, what does a architectural blueprint for machine learning looks like? So let's take basically the 3 sort of like data types that would be available in an architecture machine learning system. So the training data, the artifacts from the machine learning models, and the inference data, right? So what you would want, and your data scientists would want, is to actually use some training data to train machine learning models, right? With that, you actually produce artifacts. But that's not where the value is. The value is when we actually make use of them in production, right? For that, we want to make sure that we are delivering those models into a production use case, right? It's actually delivering value in the business side. So this is basically, either manually or introducing some CI/CD. You're productionizing your machine learning models into either real-time or batch. These machine learning models are also services that can fail, right? And as software practitioners, we know that with those services, we need to introduce operations, right? And for that, not only we need traditional monitoring that we will talk about in a minute, we also need advanced machine learning monitoring, things like drift detection, explainability, outlier detection. And all of these services will also have basically data and inference data that you may want to actually reuse in your training environments, right? So you can think of this as an archetypal blueprint of machine learning operations. So based on that, this is how we can start navigating that complex ecosystem that we saw earlier, right? Of course, throughout this, you have the metadata that flows across all of the areas and the interoperability needs that you need for all of these heterogeneous systems to interact across the life cycle. Now, as part of this, the interesting way in which organizations have been thinking about this is ultimately in the canonical stack, right? Instead of just thinking about like absolutely everything end-to-end and all of the different tools that are available, we think about it in the question of what are the architectural components, the contracts that we should have, the inputs and outputs for interoperability, and then whatever is inside, whatever logo we put inside, it doesn't matter as long as those contracts are abided by, right? So what are some common components that you would have in this end-to-end system? It would be things like feature stores. It would be things like experimentation management tracking systems, things like artifact stores, et cetera, right? So this is the way that we can start then navigating the ecosystem of machine learning operations, right? So with that, now we can take a level deeper, right? So we talked about this concept of from machine learning models to machine learning systems. Now let's also take another dimension and another consideration of model-centric machine learning to data-centric machine learning. And this is another very important trend that is actually arising in the machine learning operation space. So the reason why it's kind of like growing is because the potential of the machine learning models is not just on the models themselves, right? It's in the interconnected data-centric systems. And this will become a little bit more intuitive in a second. But this is also some of the ways in which we can think of the success of LLMs, right? So we see a lot of this retrieval augmented generation, the RAG that we've been hearing probably in a lot of talks before. The interesting thing about LLMs is that they have made the potential of general AI more intuitive, right? So this is something that is not new, right? This is something that has been used and applied and implemented since the 70s, right? But this is what I really love about the generative AI space, is that it's making the potential, the architectural, data-centric machine learning systems intuitive, such that we can think of those systems and really drive value across the organizations. Now, this is an example, right? An example is basically, just taken from Meta or from Facebook, their embedding-based retrieval system, right? So this perhaps is very complex, kind of like to just see the diagram. But the key thing to know here is that we no longer are deploying a single model, right? We are deploying an entire system, interconnected system with different stages, right? You have the offline stage to generate the embeddings. You have the online stage to be able to retrieve the queries using those embeddings, et cetera, right? So with that is just really remembering, right? This is data-centric AI systems. Data-centric because data is what really matters. And to really double down into this AI-centric piece is hammering down, right? The state of AI, the potential of AI, this has not just been caused by the rise of Gen AI. It has been largely caused by the rise of great data, right? And this is where we have to focus on, even as we think about AI, on the boring data, right? So this is kind of like the trend that was highlighted, right? Not going from model-centric, but really data-centric, thinking about how do we use great data, how do we make sure that compliance is at the forefront so that we can increase the speed for that. And of course, you hear a lot this data is the new oil, right? And that is true, right? We know as software developers, we know that garbage in, garbage out is the same thing with AI models, right? When we talk about like algorithmic bias, when we talk about risks within AI, it's largely, well, not fully, of course, but largely also within the data itself. So it is important to have those considerations in there, right? And the investment on this boring data, or what I would like to call more exciting data, is what really will drive success on organizations, what will define success or failure in the long term for teams as well that are really building AI systems. Now, so those are some architectural trends. Let's talk about security, right? So if we look at the end-to-end machine learning workflow, right? So going from data cleaning, data processing, building the model, productionizing the model, monitoring, metadata management across end-to-end. If we ask the question, where do we see a risk of security vulnerabilities? Is it at the data stage? Is it at the model stage? Is it at the deployment stage? So the key is highlighted in red, right? It's absolutely everywhere. Right? At every stage of our end-to-end machine learning lifecycle, we have risks, as we would have in security, through supply chain dependency risks, through data, data risks, through model injection risks, right? And so if we look at it some in more detail, these are some examples, right, that we actually had looked through a project that I'm going to mention in a bit. Things like loading model artifacts, right? So whoever here has, let's actually see, who here has ever, deployed a model using a pickle? A Python pickle. Okay, so we see some hands up. Exactly, right? So if we talk about just putting kind of like a microservice and pushing a like a pickle and expecting the operations team to be okay with that, I think they would probably have a mini heart attack. This is some of the considerations that we really need to like work through as an industry, as practitioners throughout the next few years. Access to the model, right? Like injections or adversarial attacks. Dependencies themselves, the supply chain vulnerabilities, code vulnerabilities, model runtime images, and the list goes on and on and on. So we actually have a security committee. If you're interested on this space, you can join within the Linux Foundation. So do check it out. We have seen also some really interesting initiatives from like OWASP, for example, that they've released the machine learning security top 10, as well as the LLM top 10. So do check those out as well. Now, there are not only trends in the security side, but also in observability. And this is to wrap up some of the trends in the technology side. So what are we seeing, right? Of course, we are seeing that as you deploy a machine learning model, you have to have the similar sort of like monitoring that you would have in traditional software, right? If you have basically like, a memory leak, right? You want to be able to know how the containers are running, how memory is actually progressing, what are the throughput, the requests per second, et cetera, et cetera. But we have to go actually beyond that, right? We actually have to look into some machine learning specific metrics. Things like, accuracy, precision, recall, RMSE, et cetera. And with that, we actually like delve into some new complexities because now we actually have state in the metrics themselves, right? In order to know accuracy, right, not only you need the inference, but you also need the actuals, right? So there needs to be some labeling that goes through that in order for you to know how the model is performing. So there are some considerations in order to introduce some monitoring at that level. Explainability is another one, right? So it is important to make sure that whenever we deploy a model, of course, this has to be proportionate to the risk involved, but often we need to introduce mechanisms that allow us to introduce explainability, whether it is through black box explainability techniques, or whether it is to just like insights and analytics on the use case itself. And then introducing also advanced monitoring, right? So things like outlier and drift detection to be able to understand when the model perhaps is decayed in a way, we can put it. And of course, one of the things that you have to consider is that by introducing outlier detection, by introducing drift detection, you're introducing a new machine learning model to monitor a machine learning model, right? So you can have bias, you can have bad data, you can have all of the challenges that you have in machine learning models in your monitoring for machine learning, right? So there are considerations, and this is why it's important for us to think about the whole stack as a whole to know how do we increase our delivery capabilities for us to be able to like build AI in a resilient way. So with that, those are some of the trends from a technology standpoint. Let's now look higher level in some industry trends. So if we think about it, and this is how you can think about it in your organization and even in your teams, navigating the journey of basically maturity. So you may start in this sort of complexity and scale, right? Like actually how much data, how much throughput, how much scale you have. You may start kind of at a lower level of complexity and a lower level of scale. And perhaps through a kind of like hyper growth or like, potential within the project, your prototype ends up in production, right? After there's a lot of potential, you end up in a situation where there is an accelerated journey with significant increase on scale, but also at the expense of a high level of complexity, right? Like you incur some tech risk, some tech debt, you incur some organizational debt, as you scale the team, as you scale the organization. But then after that, it is important to be able to repay that debt, right? Really think about how to increase the repeatability of your infrastructure, increase the resilience of your infrastructure so that you can increase that sort of like time to value deliverable. And this is where, how to think conceptually going into a larger scale with a reduced complexity, right? And this is really how I really like to think about this challenge of production machine learning. Now, let's think about it more practically, right? So whenever we actually start, if we think basically as we add more components like automation, standardization, control, security, observability, reliability, you may start with just a bunch of data scientists, right? Productionizing a few models, right? Serving a small team. As you scale, maybe you have more data scientists and you have more models. Then maybe you need to think about introducing a new role, a new persona, that of a machine learning engineer that is, concerning about the delivery of machine learning models. Then as you increase the number of data scientists, your organization grows, your number of teams grow, you actually need to build higher infrastructure for you to be able to continue delivering value. Then you have to actually think, how do you deal with that complexity, right? So you no longer have data scientists that are delivering models. You have machine learning engineers that are building pipelines, productionizing those models. But now you have MLOps engineers that are building infrastructure, doing SRE for machine learning, managing the platforms that enable the organization as a whole to deliver value, right? So now let's think about these roles from an organizational ratio, right? You're not going to be looking to have the same number of MLOps engineers than machine learning engineers than data scientists, right? The way that we're starting to see this as a trend is that with a team of data scientists, there tends to be a machine learning engineer that is delivering multiple pipelines that help productionize a larger number of repeatable models. As part of that, perhaps there are multiple machine learning engineers serving different sort of components on their platform, right? When there's a scale, a large enough scale. Then that's when the machine learning MLOps engineer is able to manage that sort of platform. And of course, this allows not just for delivering value to data scientists, but thinking about machine learning as a product, as a data product, as an ML product, or as a BI product, where analysts can actually be continuously delivering value within your AI capabilities. So this is really how we're seeing some patterns organizationally as we're thinking about scale across the teams and the delivery, right? So you can then continue scaling as it grows. So with this, there's also another complexity, right? So you cannot just copy-paste your software development lifecycle, right? Your organization probably will have an SDLC that has to be followed, right? That you go into operations, there's a process, there's a review, there's different stages of your machine learning of your production environments. But in machine learning, there are nuances that need to be considered. And the way that we're also seeing this, and the way that it's also being approached, is first and foremost, like we just saw, identifying the personas, right? Throughout the different stages of the machine learning development lifecycle. Once we have those personas, we can actually start thinking to go to the next step, right? Is defining that architectural blueprint within your organization. What are those architectural components that you're going to abide by, that you're going to try to start sort of like enabling your teams to be able to use different tools as long as it kind of like, leverages that some sort of skeleton. And then how do you then bring together those personas and that architectural blueprint into that end-to-end MLOps lifecycle? Machine learning development lifecycle, right? The MLDLC. And this is basically what a lot of organizations are really struggling and thinking through, as this is what the industry requires in order to continue, the actual speed of delivery. Of course, it wouldn't be the same as with software development in that all projects would abide by the same stages, right? The reason why is because sometimes you may have an analyst, right, that is actually delivering value with some simple models, right? And at that level, they may be using some BI tools, right? And you may not be able to leverage the same infrastructure that would be in other cases. Similarly, in other cases, you may not have the same level of risk than in other cases. So you may not require that level of scrutinization and stringency in the process in order to actually deliver value, right? So it's more of kind of like a pick and choose depending on the proportionate risk and context, right? So this is why there's a nuance involved. Now, the reason why also organizations are really like wrestling with this is because there is a new wave of regulation, right? And we're seeing not only with kind of like existing regulation like GDPR, as we're in Europe, but also we're seeing in AI regulation, right? So we now saw that the AI Act has come into is going to come into life. And this is something that now organizations are really also thinking through. How do we manage our internal operations in a way that allows us to still deliver effectively whilst doing it in a responsible manner, right? And again, how it was mentioned at the beginning, so I have been involved through the ACM, contributing to a lot of these tech policies. One of them was actually the UK's AI regulatory environment, where some of our recommendations were adopted. If you're interested, actually the ACM has a tech policy committee where, we're actively contributing to this space. Now, to provide some wrap-up thoughts, so let's actually see how we can think also about machine learning maturity, right? Because often the way that organizations think about machine learning maturity is in a linear manner, right? Is they start from kind of like analytical sort of like nuances, and then they move into prescriptive analytics and then autonomous systems. However, you need to remember that actually it is not a linear path, right? And the path becomes more around the time to value, right? From concept to AI system. Because a lot of organizations maybe have some areas that recommend their systems where they are all the way over here, right? But then they have other areas that are actually all the way there. So the question is how to get the organization into a way where they are kind of like moving fast from that perspective, so that you can invest in your maturity, in your data limitations, and also on the development speed. So with that, then let's move into some closing thoughts, so that we leave the session with some caveats, right? So that we can basically use all of these things that we've learned, but also use them with some of the premise. Now, we have to remember that not everything is AI, right? So if we look at all the problems in the world, right, and the relevant solutions, with the software solutions, the solutions that actually software is relevant, then we see that actually where AI is relevant is, not going to be a significant portion of that, right? And if we actually look closer, we can see that for Gen AI, it's even more important, right? The reason why I'm mentioning this is because when you are running with a hammer, everything can look like a nail, right? So we need to also be as conscious to understand where can we use machine learning as much as it is when we shouldn't be using machine learning to solve a problem. And a thing to also remember is that it doesn't matter, what the context is, the impact is human, right? The critical infrastructure that is now increasingly, being powered on machine learning systems, it has basically, regardless of the number of layers of software, hardware, and abstractions, the impact will always be human at the individual and societal level. So it's something that we have to also remember as we are actually deploying the systems, considering best practices, and really kind of getting value out of machine learning in production. Now, just to wrap up, if you're interested on any of the topics themselves, given that this is more of a holistic talk, I have linked a couple of resources from previous talks that I've given in other conferences that actually dive into vertically some of those topics. Things about responsible AI, explainability systems, production machine learning monitoring, metadata, machine learning security. And you can find the slides and access them on that link at the corner. So please do check it out. And if you want to access any of the resources, you just access that link. So with that, thank you very much for your time. I hope this was useful, and I hope you enjoy the rest of the conference. Thank you very much.
Thank you so much.